University Malaysia Kelantan, UMK, is an entrepreneurial university. We implement the government's aspiration to ensure the younger generations are not only highly educated but also entrepreneurial. UMK is the #1 entrepreneurial university in Malaysia and aspires to be one of the world's best by 2030. This is in line with the National Entrepreneurship Policy, which aims to make Malaysia an entrepreneurial country by 2030. According to this vision, UMK ensures the whole university functions within an entrepreneurial ecosystem. This ecosystem comprises of 9 faculties supported by institutes and centers of excellence implemented with the discipline of innovation-based entrepreneurship. The university's upper management, together with UMK employees at all levels, are committed to realizing UMK as a Malaysian public university well respected for its foundation of entrepreneurship. Implementing this ecosystem, the UMK Entrepreneurship Institute UMKEI oversees 3 other entrepreneurship-based centers: the Center for Entrepreneurship Development and Education CEED, the Institute of Small and Medium Enterprises ISME, and the Global Entrepreneurship Research and Innovation Center GERIC. The Faculty of Entrepreneurship and Business, spearheading this structure, has successfully developed collaborative entrepreneurial networks such as UMK Frontier Street, Entrepreneurship Advisory Council, and proudly led the Committee for Ministry of Higher Education Guide to Entrepreneurship Integrated Education. From the academic aspect, UMK offers 29 undergraduate programs and 16 postgraduate programs in the fields of business and management, tourism and hospitality, science and technology, as well as arts and heritage. The university is constantly enhancing its teaching and learning system to ensure that the process of learning takes place creatively and innovatively through My Academic Integrated System, My EYES, massive open online courses, MOOCs, and blended learning. UMK is committed to the development of first-class graduates to become the leaders of industry. Collaboration with world-class local corporate sectors, as well as a network of well-known regional educational institutions, is aimed at empowering UMK from various angles. This is evidenced by the increase in the marketability of graduates and graduates who create jobs through businesses. Research, innovation, and commercialization is another important part of UMK. Research funding and the number of innovations and commercialized products increase every year. UMK has performed well in various prestigious competitions. With the hashtag UMK for Society, UMK is also involved in various community activities. Our staff and students consistently demonstrate outstanding skills and abilities. With such a great spirit of teamwork, UMK has never looked back to emerge as a respected educational entity in the region. We at UMK believe that our presence will give a new look to the development of the Valley of Knowledge. Indeed, our core, entrepreneurship, will always make us, University Malaysia Kelantan, relevant, unique, and different.
of Science was established in 2012 in one of the youngest public universities in Malaysia. It is our vision to spearhead academic, research and entrepreneurial excellence in Earth Science through technological advancement.
Faculty of Earth Science currently offer 5 programs, which are 3 undergraduate programs, with 1 pre-degree science program and another 1 science foundation program. Since the niche of FSB is Earth Science, which is clearly reflected by the faculty name, the 3 undergraduate programs are focused on geoscience, natural resources and environmental sustainability.
Environmental Sustainability Program covers a wide range of disciplines related to the physical environment, such as the atmosphere, water, and soil. Besides that, we have integrated social, management, and economics aspect in our curriculum. The Natural Resources Program offers excellent opportunity for students to gain in-depth knowledge on biodiversity, ecology, conservation, molecular genetics of natural resources, and the management of our precious tropical rainforests.
In Geoscience program, we conduct various fieldwork where students collect geological data and we incorporate the latest digital technology to analyze this collected data to solve pressing real-world problems. If you happen to see groups of students wearing bright orange jackets around, that's definitely our future geoscientists.
Science Preparatory Department is a new department and need to taking care and manage of 2 academic programs. Both of these programs will need to learn biology, mathematics, chemistry and also physics.
To stay relevant, we have to be flexible. Besides flexible, we have to be unique. In Faculty of Earth Science, we have multidisciplinary research. Recently, we are focusing on the research on minerals and the fossil. Other than that, we use remote sensing and GIS in monitoring forests and urban planning. These research
Okay, hi everyone, and Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Rahazaini, your moderator for today. Welcome to FSB International Webinar. This webinar is one of our international activities in our faculty in order to enhance our knowledge, sharing experience, and also collaborative opportunity. We already had a few series of international webinar with international speakers from Japan, Thailand, Indonesia, and today we have a very special guest from United Kingdom. Okay, she told us just now is 7 a.m. in the morning, and we do really appreciate her for spending time, her precious time with us today. Thank you very much. And we also would like to take great pleasure in welcoming you to participate in this webinar via UMK TV YouTube channel and also via at official UMK Facebook. Hi, Dr. Joanna.
Hello everyone. Thank you so much for inviting me to give you
All
this
right.
webinar. And don't
Okay.
worry about the time. It's all good.
Okay. Allow me to continue some introduction for this. Yeah. The webinar theme for today is entitled Integrated Approach for Sustainable Environmental Planning and Management. Okay, as everyone knows, that environmental sustainability is the responsibility to conserve natural resources and protect global ecosystems to support health and well-being now and in the future. Exponential population growth has led to increased farming, which leads to greater greenhouse gas emissions and deforestation. Industrial and technological growth means we need more power than ever, yet our planet is reaching a breaking point. We are beginning to see the consequences of global warming on ecosystems and communities. That is why now more than ever, businesses need to invest in environmentally sustainable and socially responsible practices like using clean energy and paying living wages to secure a livable future. For today, we have two speakers. One is from United Kingdom, Dr. Joanna Zawadzka, as our external speaker, and then the second one is from University Malaysia Kelantan, Dr. Siti Hajar Yaakob as an internal speaker. Before we proceed, allow me to introduce our speakers. Hi, Dr. Siti Hajar. Hi. All right, allow me to introduce our speakers. For the first speaker, Dr. Joanna Zawadzka, she is a geospatial scientist specializing in applications of data science techniques in natural capital mapping and modeling. In her role as a research fellow, she has completed numerous research projects concerning spatially explicit ecosystem services assessments as well as digital soil mapping and assessment. Her research interests evolved around developing methods for smart space allocation, supporting environmentally sound planning decisions at various spatial scales. Over her extensive career at Cranfield University, Joanna has contributed to ecosystem services assessment for the Northern Norwich Distributor Road Natural Capital Assessment for the Oxford-Cambridge Expressway in Ecosystem Services Assessment for Nature-Based Solutions in Water Treatment Sector. She has also contributed to the creation of Soil Resilient Map for Great Britain and Soil Health and Quality Map for England and Wales, as well as Soil Map for the Republic of Ireland. Through her PhD project, has also gained experience in the assessment of urban heat mitigation capacity of green infrastructure. Joanna's master's degree is linked to interdisciplinary studies of environmental protection and geographical information management studied jointly at Warsaw University of Life Sciences and Cranfield University. She also holds a PhD degree awarded by Cranfield University in urban heat mitigation through adequate spatial configuration of urban form. Okay, then we go for the second speaker, Dr. Siti Hajar. She began her academic career as an academician at University Kebangsaan Malaysia in 2008 and continued until 2014. She is currently a senior lecturer at the Faculty Science Bumi University, Malaysia, Kelantan. She received her Bachelor of Science in Environmental Health in University Kebangsaan Malaysia and Master of Philosophy in Applied Toxicology and Risk Management at University of New South Wales, and eventually she awarded a PhD in Sustainable Science from University Malaysia Kelantan. As an academician, she has been concerned with issues concerning the quality of the environment, such as air quality and the effects of climate change on humans. As an academic in the field of sustainable studies, she has made her mission to increase understanding and enthusiasm for sustainability studies throughout the world, which is necessary for both students and the larger community. I think that's all for the introduction. Without further ado, I would like to invite our first speaker, Dr. Joanna, to give her talk. Please welcome Dr. Joanna.
Many thanks for this thorough introduction. Today I'm going to talk about spatially explicit assessments of ecosystem services and biodiversity, both for urban and rural areas, and using these state-of-the-art methods, as well as I will cover some opportunities that such assessments can give us for more sustainable spatial planning. I've already been thoroughly introduced, so I will not say much more than I have had extensive experience in various types of ecosystem services and natural capital assessments throughout my work at Cranfield. And the plan for this talk today is to very, very briefly touch upon Cranfield University and especially Cranfield Environment Center to introduce my background and the background of the university. And then very swiftly, I will move on to talking about the main topic of this talk. So without further ado, Cranfield University is a solely postgraduate university. That means we only have MSc and PhD students, and each year we have around 4,500 students on campus, and also we have around 800 doctoral students. So we are a very much industry-orientated university, an applied university, and we are number one in attracting income from industry. And also, as of recently, 88% of our research is classified as world-leading. In terms of our expertise, we have a wide variety of topics that we cover at the university, starting from aerospace, defense and security, energy and power, environment and agri-food, manufacturing, management, transport systems, and water. And obviously today I will be talking about research that we carry out in the Cranfield Environment Center. I do invite you to check out our website for it. And within the center, we specialize in transforming the digital environment through our expertise in a wide variety of topics that are connected to data science, starting from sensor technology, Earth observation, data systems, data science, citizen science, and decision support. And today I will be obviously talking about our expertise in terms of decision support. So Before I start, the very first term I have to define is the ecosystem services, because all the work that I am going to focus about concerns those services. So very broadly, ecosystem services can be defined as the benefits that people obtain from ecosystems or nature, which then contribute to human well-being. And then we can classify those services into various groups, and there is multiple classifications. However, the simplest one classifies ecosystem services into 4 major groups. So these are the supporting services, from which the provisioning, regulating, and cultural services are derived. And when we are thinking about ecosystem services assessments, we need to know various aspects of how they are being generated. So firstly, we start with the ecosystem and its biophysical structure, the processes that are carried out inside the ecosystem. Then these processes provide certain functions that then can be translated to services that people can then tangibly obtain. Those services transfer into benefits, and then we can also apply a monetary value, or not necessarily a monetary, but appreciation of those benefits. And today I will be focusing mostly on our work that concerned the assessment of the service and not necessarily the monetary value of the service. And needless to say, we need to make sure that ecosystem services are included in our planning so that the balance between our economic development and natural environment is maintained in a healthy manner. I'm going to go over a few case studies whereby those ecosystem services assessments were applied in real-world planning decisions. And the first project that we have applied this approach was the assessment of ecosystem services for the Northern Norwich Distributor Road. And Northern Norwich Distributor Road is a dual carriageway, so it's an expressway that not only contains the road structure, but also associated landscaping such as newly created grassland, woodland, scrubland. Also, it contains retention ponds for the excess water that flows out of the road, and also contains various green bridges and bud gantries. And most importantly, back in around 2013, this assessment was the first ecosystem services assessment that was included as part of the environment statement that was submitted in the planning application for the road. So the assessment was carried out for 4 milestone years, starting with a scenario where the road was not present, and then 3 following years at opening of the road, then 15 years after opening, and 60 years after opening. So we could look at the wide temporal scales of how all the vegetation can mature that was built associated with the road, and consequently the ecosystem services flowing out of these natural features. So before I talk about the results, I will briefly present how such assessments are done. So at first, one needs to collate information about spatial distribution of the relevant features of a new development, as well as the surrounding landscape. So these are typically information on land use, land cover, soils, and elevation. And then we also need some information about biophysical processes that occur within both the existing landscape and the existing land cover types within the landscape, as well as within the new development. Then once we know this information, we carry out modeling. And in our case, we were using the INVEST suite of models that address various ecosystem services, which include habitat risk, carbon storage and sequestration, sediment retention, nitrogen and phosphorus retention, as well as water yield. And also, we for this particular project, we carried out separate estimations of agricultural production, so crop yield. Because those models work in a spatial domain, we were able to produce maps of ecosystem services at each milestone year that we addressed. And then from those maps, we were able to assess how the ecosystem services were changing, both for each individual ecosystem service via the ecosystem services ratio, which was basically a division between future amounts of ecosystem service at a given locations, divided by the baseline value of ecosystem services. And then we could also combine all those metrics into one single metric to determine the overall change in ecosystem services at each milestone year. And as a result, we had graphical representations of the changes in the provision of ecosystem services, as well as maps of the changes that would identify the areas that are particularly good at providing certain ecosystem services, and also areas that are more problematic. So, as I said, the part of the results were spatial maps of ecosystem services, and as you can notice, certain maps covered only the footprint of the road and associated landscaping. This was especially for the carbon storage and sequestration service, which changes only within the footprint. However, for other ecosystem services which concern material flow across the landscape, it is necessary to consider also the wider context of a particular development. And as a result, we saw that certain services would diminish as a result of introduction of the road. So, for example, arable production would go down, and also avoided habitat risk. So habitat risk would increase. There were certain services that would initially diminish. However, as the time progressed, they would actually improve. So, for example, in terms of carbon sequestration, at first, some natural vegetation would be removed from the area that would be taken up by the road, which would cause a decrease in carbon storage. However, due to associating landscaping, the carbon storage capacity would increase over the time due to maturing of the vegetation. And similarly, nutrient retention capacity of the associated landscaping could at first would diminish, but then grow back in even beyond over the initial amount. One other aspect that is worth considering, as you can see, water yield initially would rapidly increase, and this is because we are replacing natural soil with with a sealed surface. However, it would diminish over the time, and this is because we did incorporate the effects on climate change on the temperatures and the rainfall, which those scenarios indicated that temperatures would grow and the rainfall would go smaller, and therefore reducing the amount of water generated from the scheme. And those changes are obviously easily represented by the radar plots that are perhaps a good visualization tool to present the outcomes of the analysis to decision makers. And also this type of analysis could allow us for identification of more optimal land cover changes from different land cover types. So we can start looking at what happens if we modify arable land to woodland or grassland, or what would happen if we modify initially land which was initially grassland into woodland or other land cover types. So this type of assessment would allow us to do optioneering of different potential locations for a development. So as such, it would be possible to apply this type of assessment in early stages of the planning process to identify the best location in terms of maximizing services that can be provided or minimizing losses in those services. So moving on from transportation networks, another project that we carried out at Cranfield was a European project, which was looking at combined natural and engineered systems for water and wastewater purification. And it was a large project composed of multiple work packages, out of which the ecosystem services assessment was only a smaller part of the project. And in this project, the ecosystem services approach was applied to identify any ecosystem services coming out of those combined naturally engineered systems for water purification, which did not concern water purification. So we were looking at whether there are any other benefits that those systems could provide apart from cleaning or purifying the water. So our study areas, we had three different technologies that we were looking at. We had bank filtration, by which water that was being abstracted from a river for water supply to Polish city of Poznań was not abstracted directly from the river, but from approximately 10 to 20 meters away from the river bank, which meant that the water could be partially filtrated by the soil substrate along the way to the abstraction wells. Then another technology that we looked at was soil aquifer treatment, whereby one of the processes in wastewater treatment in a Swiss city of Basel was to pump up the effluent, the partially treated effluent from wastewater treatment works into a forested area and allowing it to percolate down again through the soil and continue the kind of for it to continue the purification process. And the third technology we were looking at was a constructed wetland, which was going to be constructed within the duration of the project. And the first thing we did, we pre-screened various ecosystem services that could be possible from such systems. So we identified that most of those areas could provide quite a wide variety of ecosystem services. And then we started the modeling process. This is just to show the locations of those 3 different systems. So we were looking at Poland, Switzerland, just at the border with Germany, and Germany. So again, we were using the INVEST models to assess carbon storage, pollination, water yield, nutrient export and retention, as well as sediment export and retention. And in this case, we were only looking at one point in time, so we were not able to assess the changes over time. However, we were able to put those sites into their context. So we started looking at how the provision of various ecosystem services from the site compares to the provision of ecosystem services from the nearby land cover. And we found that in many cases, the site performed better than the surrounding land cover. However, its performance was also depended on their location and the kind of spatial context and topographical context of the study sites. So, for example, sediment retention was greater up in the hills that were the places that the sediment was generated from. In this project, we also had a chance to look at the cultural values of such systems. So these assessments were not carried out with any modeling. However, they were done by surveys, by web surveys of public preferences of the combined natural and engineered systems over purely engineered systems. And it came by no surprise that the preference was largely skewed towards the more natural systems as visually more attractive, as people potentially enjoying visiting those places more than the engineered equivalents. They would prefer to have those natural-based solutions in their neighborhoods, and they did look the green, like the green look of those features. So the conclusions from this study was that the ecosystem services provision and performance will depend on the on-site and off-site effects that would include land cover, topography, location in the landscape, and climate. And the final ecosystem services will depend on the presence of the beneficiaries of those ecosystem services, and they can also extend beyond the nearest proximity of a site. So, for example, people could visit those places and travel at a certain distance to get to them. And as I said before, those spatially explicit ecosystem services could help maximize benefits from CNES sites that extend beyond water and wastewater treatment. So yes, we did prove that those sites can provide extra benefits. So another aspect that is connected to ecosystem services is biodiversity, which often is included as a service. And before I present some of our projects, I need to say that there are two types of connectivity that about. One of them is structural connectivity, and the other is ecological connectivity. Structural connectivity refers to physical connectiveness of different habitat patches, which form like a continuous fabric of natural areas, whereas functional connectivity refers to a situation where various species can actually use those connected areas. So if you imagine that there is a species that prefers habitats that are within large patches of a certain habitat type, it would not necessarily be using small ecological corridors to move across habitat patches. And obviously it is much easier to assess structural connectivity, and ecological functional connectivity is less easy to assess. However, we have been applying circuit theory-based model called CircuitScape, where connectivity is represented by the electrical circuit theory, whereby we can specify the difficulty of movement of various species across the landscape and come up with more realistic representation of how species may move. So those assessments can be done for individual species. So this is an example from the Aquanes project, the European project, where we looked at bank filtration in the water purification process, and the model could be run for one species that was preferring natural, water connected habitats for its movement, and we could compare this movement to a counterfactual scenario where no suitable habitats are present, to identify what is the benefit of this particular sinus in terms of connectivity for this particular species. And then we were also able to make similar assessments for multiple species that were present inside the Natura 2000 network, which is a network of areas that are protected because of presence of particular species. And we could assess the role of different sites in connectivity for those species. So in this case, the location in the landscape played an important role. If those sites were not present in the proximity of those Natura 2000 sites, they obviously had lower role in maintaining the connectivity for them. And then also we did apply this type of assessment for urban areas in the context of bird species movement across the areas. And here we chose two species of tits, which are very charismatic species here in the UK, and which means that they're well recognized by humans. And this type of assessment requires that the resistance of movement for those species is identified. So, for example, large patches of woodland were preferred by those species and therefore were assigned low resistance values, and then roads with high traffic were assigned a very high resistance value because they would obstruct the movement of those species. And the resulting maps indicate that the multiple pathways where the species are likely to move. So the bright areas, the white areas, indicate the highest intensity of current. So therefore, the best likelihood that those species would use those areas. And as you can see, we can identify multiple paths to movement. So we can also, in the context of new developments, we can potentially choose areas that would cause less obstruction to the movement. So those type of methods may also be used not only for the assessment of the movement of species, of animals, but also humans. And there was a study that was carried out with our MSc students, as well as Dr. Amal. And those studies were looking at comparison of the movements of toad species and humans, and identifying any commonalities between habitat preferences. And these type of studies then may lead to planning decisions for identification of ecological networks that would be not only preferential for the animals, but also for humans, so as to ascertain multifunctionality of urban green spaces. And speaking of urban green spaces, I will now briefly talk about my research project, my PhD project, that whereby I was looking at the effects of spatial configuration of urban form on heat mitigation. And as we know, cities are burdened with the effect of the urban heat island effect, which means that cities are typically hotter than their surrounding urban areas. And it is becoming increasingly important to develop our cities in a way that are less prone to the excess heat. And studies concerning the thermal environment within the cities, we can use either temperature sensors, which are usually quite expensive to deploy and can be only put in chosen selected areas. We can use temperature maps, thermal maps sensed from aerial imagery, which can be expensive to obtain. We can then also use satellite imagery, which can be free of charge. However, they have a large footprint, which means that each kind of pixel in the image may contain thermal responses from multiple land cover types, including the hotter and also the cooler areas. And then we can also use computer simulations and computational fluid dynamic type models to identify how temperature would disperse within the cities. But these models are computationally expected. And our goal in such studies is to try to identify what would the temperature be at small scales, neighborhood scales, or even micro scales in terms of individual buildings. How can we plan our cities in a way that we can decrease the excess temperatures in areas where people live and work? So this is all fairly complicated, but I found some ways of overcoming those issues. So I set out to identify what is the impact of spatial configuration of urban form at various distances away of particular urban features, whether there were buildings or trees or grass patches or paved areas. And I looked at distances between 10 to 100 meters, so very, very close proximity to those features. Given that I had no access to high-resolution imagery, I needed first to downscale satellite-based imagery to a finer resolution that will allow me to identify temperatures of individual land cover patches within the urban areas. And then I came up with a method of identifying different patches of land cover types, so different types of buildings, different types of trees, and I found that tree cover in the nearest proximity to the buildings had a good cooling capacity for different land cover patches, and lower coverage of trees was associated with hotter areas. So this is to prove that it is actually important what is not only what is a given patch, but also what is in their neighborhood. And the biggest effects are seen just in the nearest proximity. And apart from tree cover, the spatial aggregation of the tree cover around those features, elevation and distance to water were the most important factors. And in my work, I also did apply another method of ascertaining what are the expected temperatures in a city by using the inverse urban cooling model, which is a simplified version of the representation of urban heat within the cities. And I found that the model could convincingly work for at scales that are perhaps more applicable to city districts or neighborhoods rather than individual buildings. So as a conclusion, as I said, at micro scales, abundance of trees and at the nearest proximity to buildings and other features have the highest cooling impact, as well as elevation and distance to water would also play a good cooling role, especially the latter, the water, especially in climates that have lower air humidity. In high humidity countries such as Malaysia, shading of the vegetation would have a greater role. And also simplified modeling approaches are more suitable for assessments of temperatures, perhaps at district or neighborhood scales rather than micro scales. So to conclude my entire talk, the ecosystem services approach gives us a way of having a wider view at the landscape to assess both the on-site and off-site effects of a development or existing land cover. Those assessments are driven by land use and land cover, but also require information on the processes and functions that are carried out in those land cover types. These assessments will support planning decisions in spatial domain, and they can help for identification of trade-offs and synergies between different functions. So they will give us the opportunity to choose which functions are more important and where those functions are generated within the landscape. So, for example, we may avoid building over those areas. And as such, those assessments give us an opportunity to maximize the environmental benefits and minimize losses by application in the early stages of the planning process. And by this, I would like to thank you very much for your attention. Thank you so much.
I do believe we have so many questions waiting here for Dr. Joanna, but don't worry, Doctor. We will give you time for you to have some rest. Okay. But before that, to audience, if you have any questions, please do not hesitate to drop your comments in the FB comment section here. So I will read your questions later on after the second speaker. Okay. So Dr. Wana, it seems like you have experienced so many case studies here from the Northern Norwich Distributor Road. I'm very interested with the retention ponds that you mentioned in order to mitigate flooding from runoff. I think that's a good idea to avoid, a flash flood happen at the urban area. And also it seems it really catch my, just like that, when I heard something like urban landscape connectivity, when you mention about more buildings, more traffics, there's possibility to reduce the bird species due to the movement limitation. Am I right?
Yes.
Yeah.
So they can
Yeah.
cause obstruction to species.
Yeah,
movement.
I feel sad hearing that. We want to, live happily with the birds. Okay. All right. That's all. Thank you very much, Dr. Juana. Then I would like to invite our second speaker, Dr. Siti Hajar. You ready, Dr. Siti Hajar?
Can you hear me?
Yeah, I can hear you. Hi. Doctor? Yeah, please welcome.
Okay. Did my slide appear?
Not yet. Okay, I can see it now. Yeah.
All right. Hello and good day to everyone. First of all, let me take this opportunity to thank our moderator for the introduction given just now. Okay, it is my honor to be part of this webinar as I take this opportunity to share with all of you regarding how we can use an alternative or approach like environmental risk assessment, okay, to we execute and we proceed with sustainable environment management. Okay, me as one of the academician, I don't have presentation related to our university or faculty because it's already being shown in the video just now. Okay, so I'm from the Sustainable Science Program, Department of Natural Resources and Sustainability, Faculty of Earth Science. So let's get started with my presentation. This is my outline. Okay, in the beginning, I will briefly talk about sustainable development. As already you all know about this thing. So the next thing I will try to connect with all of you. What is the role of risk assessment in the regulatory decision making? Because the decision making is the entity, is the process that can participate in the management of the environmental sustainable. Okay. Then the next thing I will share with you the issue related to environmental, which is the threat of air pollution, and how the risk assessment conducted for my previous study, air pollution study. So I will give briefly about the model and also the risks that come out from the model. Okay, just to give you to make you get the overview or get the connectivity between risk assessment application in the air pollution and also in the management. Okay, and then last we'll briefly talk about how to the concept of managing the risk. Okay. All right. Okay. As the introductions or as the overview, okay, we are aware that all of us are being exposed to so many risk factors in our life, whether we are living in our house, we are at our workplaces, or even we are at the communities area, okay, through so many factors. For example, from climate change, okay, that is occurring nowadays, okay, from air pollution episode. It could be also we get being exposed to risk factor that's driven from water issues like maybe inadequate or also due to sanitation and hygiene of the water itself. Okay, other risk factors that that can affect us is from chemical exposure, biological agents, radiations, also as well as noise exposure. Okay, so here just to show you that we are living in a condition that we need to consider a lot of risk factors. Okay, whether we live in urban or in rural, so there are a lot of risk factors. Okay, that is connected to us. Okay, all right. So when we talk about the risk just now, the risk factors that exist in our life, that's why in the global commitment, okay, we are aware about these goals, sustainable development goals. There are 17 goals that all of us work for this to achieve this goal, because we want to live in a healthy, happy life, okay, sustainable way. All right. So what is the sustainable development? Just quickly go through about this concept, okay? Because as a sustainable science student, or we are in the environment, we quite familiar with the term sustainable development. What does it mean? It means that we are giving, or we are provide development that we need nowadays at the present, without we jeopardizing what our futures need. Okay, so we have to driven the economic sector because we want to develop our country. At the same time, we have to make sure that our environment is bearable, viable. We have a good quality air, good water quality. Okay, as at the same time, we want to make sure that the social community, us, can live in a equitable, okay, sustainable environment. Okay, so that's why we have these three pillars: environment, economic, social. Okay, that is about sustainable development. So let's talk about when we want to achieve the sustainable development. Okay, here I am here today to share with all of you related to one approach, okay, which is my field of study, which is about risk assessment. We are conducting a lot of risk assessments, so I will focus more to environmental health risk assessments. Okay, so here we can see that how the risk assessment is connected to, on your right side hand, left side hand, it's about we got the information from various type of field. Okay, from scientific research. Okay, it's either from epidemiology, clinical, animal toxicology, or other type of study, okay, that will support the risk assessment, because in the risk assessment itself, we have 4 types of elements. The first one is hazard identification. Okay, the second one is we do the dose response assessment. The third one is the third element is the exposure assessment, and last is the risk characterization. In order to do the risk assessment, we need information, we need data from research or scientific research. Okay, from your left hand side. Okay, all right. From the risk assessment process itself, we will have some kind of the fourth element, which is the risk characterization. Okay, for example, water pollution, air pollution, we need to characterize what is the risk, which is it high or low, or what are the value numbers of the risk. Okay, it belongs to quantitative risk assessment, or it can belongs to qualitative risk assessment. Okay, either both of that, the finding of risk characterization will help the policymakers on your right hand side, which is the risk management, how to manage the risk, because we cannot avoid development. We need the development, we need project development. So how to handle, how to have the balance, like 3 pillars just now I show you. Okay, so the decision making is very crucial. So when doing the decision making, the inputs from studies, okay, like risk characterization, can lead or can help the policymakers. Okay, whether they want to do which one decision, whether they want to take the standards, provide control devices. I will talk more about this right hand side later. Okay. So here you can see that it is connected between what is the science fact given and what is the science policy, okay, and the policy values. Okay, so here we can see that risk assessment approach is initial, or not initial, it's an important step for the risk policy makers. Okay, let's narrow down the discussion in terms of my field of study. All right. Okay, here I think the previous speaker mentioned about urban heat island. Okay, let's start with the urbanization. Urbanization is the one of the anthropogenic drivers of ecosystem change. Okay, as mentioned by Dr. Joanna just now. Okay, the ecosystem change can lead to so many things. A part of urbanization, there are industrialization, there are land use change, there are agriculture practice that can driven the changes. One of the changes could be rapid growth populations. Okay, from that changes, it can lead to the population pressure. Okay, this thing, I guess the below part and the right left hand side is, I think, more relatable to what Dr. Joanna mentioned just now. Okay, also you can see here that all the drivers can lead to the urban heat island as well as local climate change. Okay, so from this slide and onwards, I will focus more about the connection between air quality and the health effects, because the air quality is really influenced by many factors here. Regional climate, local climate, or also global climate change. So all these changes come from the anthropogenic drivers as mentioned by Dr. Joanna just now. So I will focus more on the upper top right hand side, okay, which is the how, to which extent the air quality or air pollution affect our health. Okay. All right, here is the conceptual framework from my previous study, from my research PhD. Okay, as you can see here, the air pollution level, okay, is affected by temporal and as well as locational factors. The locational factor, it could be driven by all those anthropogenic drivers just now I mentioned. Okay, as well as it's influenced by meteorological. Okay, also the temporal events also really affecting the pollution level. Okay, eventually the level of air pollution can affect our health. Okay, in my study, I examined data, air pollutants data from within 16 years. Okay, and then I look at the spatial model as well, because I consider different location has different level of air pollution. Okay, so after I did the data from Department of Environment, I proceed with data from Ministry of Health, which is the data is related to hospitalization of cardiovascular and respiratory disease. Okay, I think I need to mention as well, recently from IARC, International Agency for Research Council, has stated that air pollution is the class 1 carcinogenic, which means that air pollution itself can cause to cancer. Okay, so it's very confirmed that this scenario is critical or is severe. Okay, so for the first part of my study, I studied the macro level exposure assessment, which is using the data from 16 years old. Okay, and it's a place and time-based approach. Okay, so I will talk more about the result later. And here I also want to emphasize that for us to do the risk assessment, we can also do it in another level, which is micro level exposure assessment, which is it involve individual based, because when we want to assess the health risks, it's really depend on individual health status. So to get more accurate finding related to health risks of air pollution, it is required, okay, to assess whether the changes caused by air pollution really occur in human system, body system. Okay, so also in my study I did that micro level exposure, which is by assessing the biomarkers, biological changes in human. Okay, but the result of that micro level exposure will not going to be discussed here. Okay, I will discuss about the macro level exposure assessment only. Okay, from the first phase of my study, here is the main finding. All right. So I did the model using OLS regression model, okay, to predict the particulate matter tank concentration. Okay, for Peninsular Malaysia. Okay, the data like I mentioned just now, I obtained from Department of Environment and also agency that provide information for land use. Okay, which is this is the predictor, explanatory variable that I use in my study that is significantly contributing. Okay, this is the final model. Okay, so here there are industry land use type. There are also traffic count and also relative humidity as the predictor variables that is statistically significant in for this type of model. Okay, so the finding here shows that an increase of one average traffic count will increase the particulate matter concentration expected by this amount, 0.33 milligram per meter cube. Okay, and also the model also showed that an increase of 1 hectare industry area, it will increase PM10. It was predicted that increasing of PM10 can occur by 0.0002 milligram per meter cube. Okay, for the relative humidity, the model showed that relative humidity indicated inverse relationship with particulate variation. Same thing goes to time. It has a positive relationship with PM10 concentration because as the time goes by, the concentration is increasing. So that's why it gives the positive relationship with PM10. Okay, the next model, when I use the OLS model, I choose the log-log model. Okay, the transformation of log-log transformation to increase the reliability of the model. Okay, then the finding from my geographical weighted regression model showed that only two variable is significantly influence the concentration, which is the traffic count and also industrial area. Okay, this model not include the relative humidity parameter. Okay, it's only significantly for two variable or three variables only. Okay, so the finding here showed that three different location which have different socioeconomic, different industrial activity driven urbanization level has significant predicted concentration level. As you can see here, the places that located in the northern of Peninsular Malaysia, eastern of Peninsular Malaysia, East Coast Peninsular Malaysia is lower concentration predicted compared to the west part. Okay, so from this model, I choose three location. Okay, these three significant location representing urban area, representing industrial area, and also in presenting lowest concentration, which is as the background control. All right. So what's next is for me to assess the risk, the health risk of this particular location. All right. So I consider these three locations as predicted from the model. Okay. So I calculate or I perform the this Poisson regression model to predict what is the risk for cases, hospitalization cases for cardiovascular and respiratory related disease, because I want to confirm that it is related between the causes and the effect. Okay, so the findings showed here that after an increment of 1 microgram of meter cube particulate matter 10, the results of risk for cardiovascular is 0.3% significantly increased. Okay, whereas for the respiratory, it is 0.5% significantly increased. Okay, when it related to respiratory hospitalization. Okay, so here we can see that it's showing that particulate matter 10 is a factor for the health effects. Okay, so let's look at the location or the spatial selection location from the model. Okay, I consider the location Balok Baru and Seremban just now. So here the risk for the cardiovascular in Balok Baru is around 4.448, whereas for the Seremban is around 5.458. Okay, and for the respiratory risk, people who live in Balok Baru has risk 3.721 higher than people who live in other in other place than study location. So these two locations, Balok Baru as a industrial area, Seremban as an urbanization area, is showing that the risk for people living there regarding the cardiovascular and respiratory hospitalization is high. Okay, so let's look at using the example or using the result from my previous research. It is important to know how to manage the risk because it's already know that the risk is high. Okay, when we talk about air pollution level, it's proven from the model. Okay, so what's next is we need to come out with risk statement. Okay, the risk statement can be provided, can provide the valid and reliable information for the decision making. Okay, and then what's next is we can do the risk management by implementing mitigating measures and also perform the monitoring. Okay, that is the last stage of managing the risk. Okay, so let's now look back at the previous connection that I showed you just now. Okay, as the risk characterization in my study previously showed that high risk for cardiovascular and also for respiratory. Okay, so the result can be the baseline information to the policymakers. Okay, what is the best thing to do regarding this issue? Okay, do they need to take action seriously, like providing more information program, okay, like giving more economic incentive for the industry, okay, such as, for examples, industry that manage to apply green technology or manage to reduce their emission. Okay, they can get incentive, or maybe the government can proceed with the carbon reduction policy so that the industry can comply the exposure that is supposed to be met. Okay, other things that policymaker can proceed in their risk management is using technologies nowadays to provide control devices, for examples, okay, so that the emissions of the pollutants can be reduced. Okay, all right, as the conclusion for my talk, the environmental risk assessment is an approach that is connected to various fundamental knowledge with sustainable environmental management. Okay, it shows from the figures that connected the three things just now. Okay, so hence, regardless of who we are, okay, we are aware that a holistic and integrated approach should be used in ensuring that we can achieve the sustainable development goal. Okay, so regardless who we are, either we are scientists, we are academicians, we are the students, we are the policymaker, we should do our best. We should give the best for us to support the sustainable development goal. Why? Because we want to make sure that our future generation also have the best environment or best living condition. Okay, I think that's all from me.
All right, thank you very much, Dr. Siti Haja. Such a very, very interesting finding, yeah. When I look at your map showing the high-risk location and showing the hotspot area that has risks for health, that can cause health issue to the people, I think this research is great. I would love if this research should be presented to those policymaker probably, so that they can see the real figure, what is happening to our air.
Yeah,
To
that
our
should be done.
environment. Yep. Yeah, so that we can mitigate at least to reduce the risk to the people.
Yeah, provide the proof,
A
right?
better,
The
yep,
data can be.
yeah. So, all right, that's all. We have finished our second speaker. So now come to the exciting session, which is Q&A session. And I think, let me see the questions. Okay, we got one question, many questions actually. So let me read the question first. I think this is for Dr. Joanna probably, because this question comes first. Okay, this is from Woon JC, Facebook. Okay. I am a student of Environmental Sustainability Program FSB UMK. How can we contribute to the community and indirectly protect ecosystem services?
Thank you so much for the interest and for the questions that I can see in the chat. This is a very good question. What can we do as people, as individuals, to be able to protect and enhance ecosystem services? I think this all depends on our situation. So, for example, if we live in houses that have gardens, we can ensure that our gardens are suitable for biodiversity. So we can ensure that we have plenty of vegetation, native vegetation, that would be utilized by the native species of insects, of pollinators, of birds, and other creatures. So we can ensure that basically our gardens are not paved over too much. But many of us don't have a garden, so we can't really do that. But I think it's all about awareness raising. So we can talk to our colleagues, our friends, our families about the importance of the ecological aspects of our environment. We can also, because once a lot of people know about those issues, then this information may then trickle into our decision makers, our planners, and the planners and policymakers will understand that for us, the environment is important. And that's that's how they will start making decisions that enhance the quality of our environment.
Definitely. Yeah, I agree with that. Thank you. Hope that answers you, Won Jessie. Okay, let's move to the second question from Muhammad Rushaidi Amin. Hi, I'm student from UMK, and of course, yes. And I want to ask the question, how or what the importance of spatial GIS in environmental planning and management? Okay.
Yeah.
This is I think it's a basic one. The importance.
It is important. So in very basic terms, we can, GIS or CAD systems are used to display the current land use and also the new land use that is proposed within a development, a new building, residential area, a road, a railway, any other development that we can think of. However, the sort of methods that I was talking about that incorporate the GIS, so all those maps that I have been presenting, they have been compiled in the GIS, but with the associating modeling of the environmental functions, those ecosystem services. And whilst we have the models, the model outputs, which are spatial maps, we can then identify areas that are particularly high in those benefits and therefore should be avoided, or you should avoid developing on those areas. But also, if you have a development and you are planning as part of the development some natural spaces, you can, for example, include this development in poor areas and enhance the value. So we as people can also contribute to the enhancement of the state of the environment. Or if there is really, we cannot really avoid building on those more valuable areas, again, with the appropriate landscaping, we can try to retrieve at least some of that initial function. So this is all done within the GIS. So the GIS has a massive role in the planning for sustainability.
All right, thank you, Joanna. Hope that answers you, Muhammad Rushaidi. Okay, for the next question is from Nick Nor Shamila Mila. Hi, good afternoon, madam. I'm a student from UMK and I want to ask, what is the current or new technology to evaluate ecosystem services and could benefit the community?
So that's I mean, a lot of the things that I was talking about are the state-of-the-art methods. So they are the current methods that we can use to evaluate the state of ecosystem services. So these are obviously modeling methods. So they're kind of simplifying the state of the functions of the environment. In other ways, you could try to go out and sample various aspects of the environment that you are interested in. So you can, for example, but the sampling obviously is more costly, so you have to plan it appropriately. And then perhaps inform your models by the sampling that you have done. I think, I would say sampling as much as we can, because sampling will give us the current state of information of what's going on with the environment. And if sampling is not possible, or if we are looking into the future of how the changes may be, then we need to resort to either models of the kind I was talking about, or we can also replace space for time. So we can sample within areas that have the future. So if our initial area has a certain future trajectory, we can start looking at other areas that have that future state and see whether we can use whatever the state of the environment is there to predict what could be in our particular area. But we have to really be careful that the spatial context, the landscape context is similar, because it's not only what's happening on the site, it's also what's around the site that matters in terms of various environmental functions.
Yeah, true. All right, so hope that answers you, Nur Shamila Mila. Okay, for the next question from Nur Fatia. Good afternoon. I'm student from UMK. How spatial GIS can help in water quality and wastewater management?
Okay, so here we have two aspects. One of them is water quality. And I will understand this as water quality in our surface water bodies. So our rivers, lakes, and so on. So water quality in such water bodies is affected by what gets into them. So we are looking at the runoff from the surrounding landscape, from the catchment area, and the runoff may contain either pollutants from the agricultural fields. So the typical ones we are talking about is nutrients such as the fertilizers, so not nitrogen, phosphorus, but also sediment. So if there is soil erosion in the catchment, then obviously the excess sediments will go into the water bodies and pollute them and cause excess sedimentation. So using the GIS methods and various models, some of them which are as part of the INVEST package, but there are also more sophisticated models that use spatial data and the information on the topography to predict how much of the excess nutrients, excess sediments, excess pollutants may enter the water bodies. And also they will have identified the areas that cause the most damage, the most pollution. And then those areas could then be, there could be appropriate management put in place to prevent those excess effects. So yes, that's the GIS combined with some sort of modeling. And then for wastewater management, so again, depending how we manage our wastewater, if it's, for example, excess rainwater because of very heavy rainfalls, we can build areas which will hold this excess water. So we need to find a suitable area that will hold, has enough capacity to hold the volume of the water and also be in suitable locations from which water can go. So, for example, in cities, we have a lot of surface water flow during rainfall, and therefore we would need to find an area where we can redirect the water and the water would naturally go to. And this is again done with the use of spatial information, so GIS and some sort of modeling. And also with those technologies I was talking about, such as the constructed wetlands, again, you would need to identify a suitable place for that using information that is within the GIS. So these are the things that immediately come into my mind to answer this question.
All right. Thank you very much, Dr. Joanna. So, Nur Fatah, hope that answers you. Okay, next question is for Dr. Hajar. Okay, Dr. Hajar. This is question from Aisha Nawawi. How the Malaysia perspective practice the risk assessment when starting any type of development?
Okay, thank you for the questions. Okay, for the Malaysia perspective, okay, we do have practice in employing the risk assessment. Okay, for examples, in Malaysia we have Environmental Quality Act that in the act stated that any development project need to conduct environmental impact assessment, okay, the EIA. So that phase is before should be done prior for any project development. Okay, so in that EIA process, the initial phase of any development process, it require it depends on the type of development. For examples, okay, under the EQA, the act, it shows that for the Schedule 2, okay, any development listed under Schedule 2, prescribed activities, okay, it has to conduct the hash impact assessment, which is they need to address all the risks. Okay, this type of project development required for all this listed in the Schedule 2. Any project development listed in the Schedule 2 is some kind of project that very sensitive. Okay, it has high risk. Okay, that's why it needs to conduct the health impact assessment rather than EIA, common EIA, which is it's not for those that not listed under the schedule 2, they only need EIA without health impact assessment. Okay, so yeah, that is what Malaysian been practice. Okay, when they want to make any development, they need to conduct the EIA. Inside the EIA, there are certain condition under listed schedule 2. They need to do the risk assessment or health impact assessment. Okay, I think that would answer the questions.
Yep. All right, thank you. Hope Aisha Nawawi, you get the answer from that. And the next question is from Dr. Amal Najiha itself. Great sharing, Dr. Hajar. Which population could be high risk from your research finding?
Okay, thank you, Dr. Ahmad, for the questions. Okay, from the finding, it shows that population who live in area like highly urbanized, okay, industrial area, nearby industrial area, showed high risk of getting affected from the air pollution. Okay, in terms of population like that one is by location. Okay, in my study, there are also another phase which is use different individual level. Okay, I just want to share with all of you. That phase of study use different population. I mean, it has data from different gender, different age group, different race. Okay, so from that stage, the initial finding showed that not really significant affected. Okay, not really significant different. Okay, so maybe due to the biomarker itself, biomarker itself that I choose not sensitive for the detections. Okay, but however, in back to my answer just now, the population, which population could be affected or could be high risk, should be related to location they live, whether it's located in urban or rural. So my study found that it's in the urbanized area, industrial area, very high risk. Okay, I think that would answer Dr. G.
Okay, and here comes the last question, I guess. Hope this is the last. It comes from a student, Muhammad Nazir. Assalamualaikum, Doctor. I am a student of Environmental Program in FSB UMK. My question is, how does air pollution affect humans and how far it is related to spreading of COVID-19?
Okay, thank you, Muhammad Nazir, for the questions. Okay, in my presentation, I did mention that air pollution is really associated with human health. It can cause to cardiovascular disease. It can cause to respiratory disease. It is confirmed class 1 carcinogenic. Okay, so it does affect human health. But maybe you will have interest to know to which extent that effect. Other than my finding, more towards hospitalization case. So maybe you can proceed with my suggestion from my study can proceed with determination of the effect at molecular level, because to confirm the etiology of the disease or to confirm the human health effects, it's really need to be assessed by molecular marker. It's more accurate. Okay, I think that's answered the first questions. The second question, how far it is related to spreading of COVID-19? The relation between pandemic and air pollution, you can see here, it's the pandemic association with air pollution by when we have the pandemic, it lower the pollution level because during the pandemic, a lot of people staying inside their house, a lot of economic activity need to slow down, and a lot of transportation or vehicle number being reduced because we are not allowed to move like usual. Okay, so during the pandemic, it does affect the air pollution level. We can see from the research showed that the level of air pollutants, it could be gases, it could be particulate matter, dramatically decreased during the pandemic. Okay, but here
That
he wants
means
to know.
we are more green during the
Yeah.
pandemic.
Yeah, but the question, I guess, he wants to know how far it's related to spreading. You have to know when you talk about spreading of COVID-19, you have to know what are the causes, what are the agents. COVID-19 is caused by virus. Okay, so you want to know where the virus can be carried by air pollutants. Okay, so that one is more different compared to chemical characteristic of air pollution, because mode of transmission for virus is different, because it needs it has a sporadic pattern. It needs to be host so that it can grow. It can live. So I guess the air pollutant itself not really directly cause the spreading. Okay, so maybe it can through indirect, because when we are aware about the pandemic, we are more stringent related to our hygiene. We are more aware about distancing. We are more aware about our activities. So maybe that would answer the questions.
Okay. It seems like one more questions. Okay, from Uzair Uja. I think this is for Dr. Siti Hajar. Assalamualaikum and greetings. I am also a student of environmental program in FSB UMK. May I ask Doctor, how can risk assessment can help in assessing the impact on air?
Okay, thank you for the questions.
How can risk assessment can help in assessing?
Okay, when we want to assess the impact of air pollution, for examples, okay, I think I have shared with you the step of conducting risk assessment. Okay, so when we conduct the risk assessment, the four elements of the four steps, we follow the step. Okay, we get the information from the scientific database. We perform the monitoring. We perform the sampling and all those things. Okay, that is part of risk assessment. So when we do that, then we can assess the impact, whether it is high risk or low risk. Let me give you the example from my research just now that I shared with you. I've conduct the risk assessment, okay, using the exposure duration like 16 years old. Okay, so in my exposure assessment, I include the spatial and temporal characteristic in that exposure assessment. That is part of the whole risk assessment process. Okay, then from that spatial prediction, as I showed you earlier, it shows that the impact on air is proven to cause high risk of cardio and respiratory hospitalization related disease. Okay, so that is how we can use the risk assessment, okay, when we want to assess the impact of air. Okay, am I answering your questions?
Okay, I think that's all for today. We had great time together today. And before we end this webinar, once again, I would like to thanks to our speakers, firstly to Dr. Joanna for spending her time with us. It should be 7 a.m., 8 a.m., 8 o'clock in the morning at the moment probably. And she has sacrificed her time for us here. But here is 4:50 at the moment. Okay.
Yeah, it's almost 9 now, but it was my pleasure
almost
to be
9
with
now.
you.
Okay, good morning, Dr. Joanna.
Thank you.
And
Good
then,
morning.
okay, thank you very much for your time. We do really appreciate that. And also to Dr. Siti Hajar, thank you very much also for your time,
Thank
spending
you
your
for
time
having me.
for great sharing and give me lots of insights about air pollution. Dr. Joanna give me lots of insights about your case studies. I learned a lot from you guys. Okay, so that's all from me. That's all from FSB International Webinar. Hope to see you again. Bye. Assalamualaikum and have a good day.
Bye. You too.